All right, so we have angle-angle similarity. And it says if two angles of one triangle are congruent to the corresponding angles of another triangle, not anther triangle, another triangle, then the two triangles are similar. Okay, so this is not a congruent thing with you know, how we had to have like angle side angle or something like that for congruence. This is just for similarity. So if you have two angles that are congruent between the two triangles, then the triangles are similar. Okay. Basically, it works like this. Okay, I have two triangles, and I want to decide if they're similar or not. Let's say this one is 80. It's not, but let's just say it is. Those are both 80, and this is 50, and this is 50. Okay, if these match, these are congruent, right? I have 80 and 80 and 50 and 50. That adds up to 130. That adds up to 130. So I know that the leftover angle here has to be 50, and here has to be 50 also, right? And we know, I mean, that's just from subtracting angles. And if I have two triangles with the same angles, they're similar. And all we have to do then is show that they're in proportion. But if we have the angle-angle similarity postulate, then we can just say they're similar. We don't have to do all the other work. Give me my pen. Thank you. Okay, so to determine if these two triangles are similar, that are combined together, I'm showing that these two angles are congruent, and then I have this common angle. I take them apart, and I draw two separate triangles. I have one pair of congruent angles and two pairs of congruent angles. And since I have two pairs of congruent angles, they're congruent by angle-angle similarity. And this is separated out just because it's prettier than I could draw it. I was going to take that out, but then I thought I'd leave it because I don't draw that pretty. But we have this big triangle here, right? And as you can see, this is one angle. Here's the other congruent angle to this angle. Those are the two angles that are marked congruent. So I take the big triangle and I just duplicate it. Okay, and leave everything marked the way it is. Then I take and I draw a smaller triangle, putting that angle in the top, and then from there I say, okay, the long leg coming off of that angle is 16, the short leg is y, which leaves x to be the other side. So, okay, I will draw, but I'm going to use my cheat. Okay, so I draw the big triangle. Okay, and I label it exactly the way it is. And put my congruent angle in the top. Then I draw a small triangle. And I start with my congruent angle. Oops. I start with my congruent angle. And then I look over here and say, okay, I have this angle, and on the short side of this angle, looking here, I have a long side and a short side, right? On the short side is y, the long side is 16, so that leaves x.
What? So when I like this, you just have to separate them?
Yeah, separate them. And that way you have two triangles that are similar, and I know they're similar because Why do I know they're similar? They have one angle. Oh, this angle's in common. Sorry. It took me a second. This angle right here, they both share. Right? So that would be this angle and this angle. They share that angle. That's this corner over here.
These two bottom triangles don't even look like the top.
This one? This one right here?
Yeah, they don't even look like
Is that one?
Because that one has a straight edge. Neither one of those even has a straight edge, and they share the same exact side.
They don't have a straight edge. This side right here is this part right here. It's just like the small triangle is kind of rotated inside the big triangle. Okay, I'm gonna go over it again. Okay, so I draw two triangles. Okay, and I look at the big triangle I keep exactly the same as it is. Okay. And I go ahead and I mark that angle that's been marked as congruent up in the top corner. Okay. And then I take the small triangle, okay? And I know I'm gonna have the small triangle, so to figure out how to label it, from the little triangle, I start with the congruent angle, because that's this angle down here that's been marked. Right? If we look at the original picture they gave us. Okay. You see that this top corner here is marked congruent and this bottom one down here. So these two are congruent angles, because they're the only angles that are marked. Okay. So I start with that. And then I look at that angle over here and I say, okay, I have a long side and a short side. So long side, short side coming off of there. The short side is Y. The long side is 16. And that leaves just an X.
Well, wouldn't you put the other congruent mark in there?
Mm-hmm. Because see here, that's the top angle right there. And then there's this little angle right here. So that goes up here.
Is that just the top angle in the big triangle or the little triangle too?
No, this is the top angle in the big triangle, and then this is the angle that we make the top angle in the little triangle. So basically pull this little triangle out and we turn it.
Right, but shouldn't that on the little triangle still have another congruent little thingy?
No, that's this one right here. See this red mark here is for this big angle, not the little part.
Oh, okay, okay.
Does that make sense? It's because it's the whole angle.
I was just like, oh.
And then we know they're similar because they share this angle right here in common. So that's the two angles. They have to have the two angles to be similar, and they share an angle. So if they share an angle, it's the same angle, right? So it's congruent. Once we have them labeled, this X and this X are the same, right? Because they're the same side. Did you see that? So we have to solve Y first. Or sorry, no, we have to solve X first. Y depends on X. Did you see that? Okay, hold on. Give me back my thing. Okay, so what we have is these two X's are the same, right? But this X and this Y are the same side. So in order to find out what Y is, I first need to find out what X is. And I can use this X to do that. So I use this X over 30. Oops, let me use a color that will show up. And that's equal to 16 over 32. Okay. And now if you look at this, 16 and 32 will reduce to 1/2. So I get 2x equals 30. So x is 15. So this x here is 15. This x over here is also 15. Right? Then to find y, I do y over 15 is equal to 16 over 32, which again reduces to 1/2. So I get 2y equals 15. So y is 7.5. Okay, so when you have a triangle situation like this where you have two sides are the same variable, you find that variable first. And then you can use that answer to find the other variable.
How do you know? Oh wait.
I can make another example like this, and you guys can just kind of do it off to the side. Would you like that?
Yeah, but I have a question.
Okay.
How did you get 15? I don't understand. How would you know how to put the x over the 30?
Because this side is similar in proportion to this side. So what we have here, let me use the highlighter. This side, that's too fat. This side, that's ugly. This side goes with this side. Right? This side goes with this side. And this side goes with this side. So then that x and that 30 are together.
Oh, I see.
And then the 16 and the 32 are together.
Yeah, I just got confused.
No, it
I wasn't
happens.
paying attention.
Happens. Okay. So what I'll do, I'll make another one. So first I'm going to draw our big triangle. Love this feature. Okay. And then I'm going to say that this angle is congruent to that angle. Okay. I'm going to call this x. I'm going to call this one, no, this one y. Hold on. Yeah, okay. This will be 40. And write that prettier. Right, this will be 40. This one will be 10. And this whole length here will be 80. Okay. So what I do next is I draw two triangles, one big and one small. Oh, not that one. Okay. I didn't draw them exactly the same, but it doesn't matter. I know what I'm doing. Like, I know that I'm saying that these two look like that. Okay. And then I label the big one. So the big one I label exactly like the original drawing. So this is y, this is 40, and this is 80. Okay. Any questions about labeling the large one? That one's usually the easiest.
Where does 10 come just said.
That's part of the small triangle, right? And so now what we do is we look at this small triangle, and here's the congruent angle. So that's my top angle, because it's the top angle on the large one. Yeah.
I don't know if it's 80.
Because this line here tells me that means this whole side is 80.
Oh, was this just a drawing?
Huh?
Yeah.
Yeah, this is just an example, yeah. Okay, so I mark this angle, that's this angle right here. And I put it in the top corner, because in the large triangle it's in the top. Okay, and then I look at, I have a long side and a short side. My short side is x, so my short side is x. And then my long side is 10. And that leaves a y. Right, so I have x, 10, and y on this triangle. So if my short side on the angle is x, my long side on the angle is 10, that means this side over here has to be y. So you base your labeling off of that angle. So now that we've got it labeled, we can see that y goes with 80. And 10 goes with 40. And then x goes with y. And this right here, x going with y, the letter that shows up twice is the letter we have to solve for first. So on this one we solve for y first. We do y over 80 is equal to 10 over 40. Okay, which if you want you can reduce that to 1/4, right?
How do you know which one is on first?
Y, we have to find y first because there are two y's. So if there were two x's, we'd find x first. If there are two y's, you find y first. So 10 over 40 reduces to 1/4. So I get 4y equals 80. So y equals 20. Okay. So now I know what this side over here is 20. So now I know what x goes with is 20. So I do x over 20 is equal to 10 over 40, which we already know is 1/4, right? So 10 over 40, which is 1/4. So I get 4x equals 20, so x is 5. So let's try some more of these. Now here we have not joined, right? These are the easier ones. The one where they are joined, though, is basically the same as this, only they're already separated. Yeah. So we'll do A. No, I'll let you guys do A. So I'll pause, you do A, and then we'll work on B, C, and D separations together. So on A, the sides that go together, we have x goes with 4. Y goes with 5, and 3 goes with 6. Yeah, so you'd have x over 4 is equal to 3 over 6. So 6x equals 12. So x equals 2. And then y over 5 is equal to 3 over 6. So 6y equals 15. So y is 2.5. Okay. Now for B. All right, we have two triangles together, so I'm just gonna ugly. I don't like that one. Draw a big one and a small one, right? Okay. I have that this bottom angle is, and this bottom angle. Okay. So labeling the top, or the big one, that's pretty easy. This big part is 12. This is 9. And this is also 9. Okay. On my small one, this one's a little easier because it's not rotated. So I have 3, y, and x. Okay. So 3 goes with 9. This y goes with this 9. And x goes with 12. Yeah, x over 12 equals 3 over 9. So 9x is 36. So x is 4. So just in case anybody needs it, that's cross multiplying. And then y over 9 is equal to 3 over 9. Do I even need to cross multiply this though? If my denominators are both 9, what does y have to equal for these to be equal? 3. Does that make sense? So if you have matching denominators, your numerators have to also match, otherwise they're not equal. So y has to be 3. This one. Okay. Now in this one, actually we don't have any rotation again. So when we separate this, I'm going to have, that's not pretty. This triangle, and then a little version of, no, a littler version of that same triangle, right? This is the bottom angle here, same bottom angle. So when I label this, this is x. Oops. This is x. This top part is 15. This side here is, no, I have a y and a 4. I don't know what y equals, so it's just 4 plus y. Okay, on my small one I have y and 6 and 10. Okay. Do you understand why it had to be 4 plus y? Because we have to add these to get the 15, right? So we have to add these to get whatever that is. Okay. So for labeling purposes, y goes with 4 plus y. And that's okay because they're the same letter. And you'll see in just a second why that's okay. 10 goes with 15. And 6 goes with x. So why don't we do x first, because that's going to be easier. So if I do x over 6 is equal to 15 over 10. So 10x is equal to 90. So x is 9. So, 6 times 15. And in case you're wondering how I did that so fast in my head, I said 2 times 15 is 30, but then I still had to multiply by 3 because that to make the 6. So. All right, so now with the y's. I still have the 10 over 15. That part didn't change. I have y over 4 plus y.
If you switch it.
Oh, I don't have to switch it. I just switched it to do small over large, but we don't have to. We can keep it the same. I could do 15 over 10. And then I have 4 plus y over y. Okay, and then I'm going to cross multiply. And this is going to give me, I'm going to run out of room, but 10 times 4 plus y is equal to 15y. Right? And if I distribute that, I get 40 plus 10y is equal to 15y. Does that make sense? So I have all y's. And I can subtract 10y from both sides. And I get 40y is equal to 5y, or sorry, not 40y. 40 is equal to 5y. So y is 8. Let's try D. Okay, so D. Okay, see, this one doesn't rotate either. All right, well, I have big triangle, I have little triangle. Okay, this angle is the same in both. They're not congruent, because congruent would mean they were the same exact size.
But the middle, and then they have the two of the congruent angles, what is that? That's off something.
Two congruent angles means they're similar. And if they're similar, that means they're in proportion. So basically what I'm saying is these two triangles, like this big one and the little one is just shrunk down from the big one, but they're the same exact shape, different sizes. So to label the big one, this is X. This side for the big is 6 plus 3, so that's 9. And here I have y and 4.5. So I have to add those together. Okay. Now my small triangle, this is 9, this is 6, and this is y. Questions on the labeling?
I get that all the time, so to me it's not shocking.
It's still adorable. Okay, so questions on the labeling? Okay, so we're going to do X first just because there's only one of them, so it's easier. But let's do 6 goes with 9, right? This 9 goes with this X, and then these Y pieces go together. Right, so X over 9 is equal to 9 over 6. So 6x is equal to 81. So x is equal to whatever 81 divided by 6 is. 13.5.
Well, how come on that one you couldn't just do it the other way, like the 6 over the 9?
I could have if I had put the x on the bottom. Because I have to do, what I did was large over small, large over small. So you always have to keep the same size triangle on the same side. So if I did large in the numerator on this side, I have to do large in the numerator on this side. If I do small in the numerator, then I do small in the numerator.
We don't know what X is.
Right, but we know that this triangle is larger than this triangle. Does that make sense? Okay. Now for Y, do you want to do small over big or big over small? Just pick. Okay, we'll do big over small. So I have Y plus 4.5 over Y is equal to 9 over 6. Actually, I'm going to rewrite that on this side so it makes more sense. Okay. So when I cross multiply this, I get 6 times Y plus 4.5 is equal to 9Y. And then I distribute, which gives me 6Y plus, I'm being lazy, 27 is equal to 9Y. And if I take 6Y from each side, I get 27 is equal to 3Y. So Y is 9.